Welcome in mechanical system design subject. Today we are discussing about the design of IC engine components. So today we will see the design of IC engine component, which is a valve spring. So here we will see the design procedure for the valve spring. First of all, we'll discuss about the inlet valve spring. So let us assume the spring material is 55 SI to MN90. Therefore, the composition of spring material are as follows. So it contains 0.5 to 0.6% carbon, 0.8 to 1% manganese, and 1.5 to 2% silicon. Then the ultimate tensile strength for the material is lies between 160 to 200 kg per mm square. Then SYT is 150 kg of per mm square. Then modulus of rigidity G is equal to 82 into 10 raised to 3 Newton per mm square. Therefore, material for wall spring. So the initial force, spring force, we are going to calculate by using the formula Fi is equal to area of wall into maximum suction pressure. Therefore, we'll get Fi is equal to pi by 4 dV square into PS. So here PS is equal to 0.045 Newton per mm square. So for inlet wall, Fi is pi by 4 dV square into PS square, not PS square, dV square into PS. So the diameter is 50 mm and PS is 0.045 Newton per mm square. So the for inlet walls force Fi is equal to 88.3572 Newton. The force required to lift the wall Ft is given by, assume K is equal to 12 kilonewton. Therefore, Ft is equal to K into Bm. Therefore, for inlet wall, Ft is equal to 12 into 17. So, Fl or Ft is equal to 204 Newton. So, the force required for to lift the wall Ft is equal to 204 Newton. Therefore, Fl is equal to, it can be represented as Fl or Ft 204 Newton. So this is for inlet wall. Then for exhaust wall, again force required to lift the wall is equal to 12 into 16. So that will be equal to 192 Newton. Then for inlet wall, maximum force is a sum of Fi and force required for lift for the inlet wall. So F max will be equal to 307.50599 Newton. So this is the actual total maximum force required for the inlet wall to operate. Next is the F minimum. F minimum is always equal to the Fi. So that will be equal to 103.0599 Newton. Therefore, F max is equal to Fi plus Fl for the second case. So 88.35 is the Fi and 192 is the Fl. Therefore, F max will be equal to 80.3572 Newton. So F minimum is equal to Fi is equal to 88.35 Newton. Then next is the wire diameter for inlet wall. The mean force Fm is equal to F max minus F minimum upon 2. So putting the value of maximum force and minimum force, will get mean force as a 205.0599 Newton. Then Fa is equal to F max minus F minimum upon 2. So that will be equal to Fa is equal to 102 Newton. Then assume spring index C is equal to 10. We are having Ks is equal to 1 plus 0.5 by 10 and therefore Ks is equal to 1.05. Now Kw is equal to 4C minus 1 upon 4C minus 4. So by using this formula, you'll get the Kw is equal to 1.14483. The mean shear tau m and shear stress amplitude are given below. So by formula, tau m is equal to Ks into 8 times Fm into C by pi d square. So by putting the value, we will get the tau m is equal to 5482.89 by d square. Similarly, tau a is 200 2973.5913 d square. Assume factor of safety NF is equal to 2 and ultimate strength is equal to 180 into 9.81, so it will be 1765.81 Newton per mm square. Now SSY is equal to 0.45 into SUT. Therefore, it will be equal to 794.61 Newton per mm square. Now H dash SE is equal to 0.22 SUT. Therefore, it will be equal to 388.476 Newton per mm square. Therefore, the wire diameter can be tau A upon the SSY upon NF minus tau M is equal to S dash AC by 2 divided by SSY minus S dash AC by 2. Therefore, putting all the value in the form of diameter, you will get final diameter d square is equal to 36.9359. Therefore, d is equal to 6.077. So the round value or standard value for the wire diameter d is equal to 8 mm. Then mean diameter d is equal to c into d. Therefore, C, that is the index, spring index is 10 and wire diameter is 8. Therefore, mean diameter is equal to 80 mm. Then the number of active coils NC is equal to the formula is used as a G into D by 8C cube K. So by simplifying all the value NC, or we will get the number of active coils equal to 6.833 mm. So that will be equal to 7 turns. The total number of coils N dash C, the square and ground ends are used for the wall spring. Therefore, N dash C is equal to NC plus 2. Therefore, N dash C is equal to 9 turns. Next is the maximum change in length, that is the delta max is equal to maximum force upon K. Therefore, that will be equal to 307.05 divided by 12. So, delta max is equal to 25.5883. Next is a solid length, it is represented by LS and it will be given as a NC plus 2 into D. By putting the value of NC, that is the number of active coils 7 and wire diameter 8. So you will get the LS, that is solid length for the spring equal to 72 mm. Then free length for the spring LF is equal to solid length plus maximum compression plus total clearance in the compression condition. So that will be LF is equal to LS plus the delta max plus 0. So LF is equal to LS plus 1.15 into delta max. So that will be equal to 101.4265 is the LF, that is the free length for the spring. Next is the pitch of the coil, that is a small p. So LF is equal to P into NC plus 2D is the formula for pitch of the coil. So P is equal to LF minus 2D upon NC. So by putting the value of LF, then diameter, wire diameter, and number of coils, active coils 7, we'll get the pitch of the coil equal to 12.2037 mm. Next, wall spring, that is the exhaust wall. The mean force for the exhaust wall will be the maximum force plus minimum force by 2. So by putting the value of F max and F minimum, we will get the mean force for the wall spring, that is exhaust wall, 184.3572 Newton. Then Fa is the accelerating force, F max minus N minimum upon 2. So that will be equal to 96 Newton. Then assuming spring index as a 10, again we are calculating the Ks is equal to 1 plus 0.5 by C. So Ks we will get the 1.05. Similarly, we calculate the kW, that will be the 4C upon minus 1 upon 4C minus 4. So that will be equal to plus 0.615 by C. So finally, we get the kW is equal to 1.14483. Then mean shear stress tau m and shear stress amplitude is given by this formula. Tau m is equal to Ks into 8 FMC by pi d square. So we get the shear stress in the form of diameter, and another equation for the tau A acceleration or another stress value in the form of d square or d will be 2798.67 by d square. So the material for the spring is same as that of also same. The material for spring is same, so the properties are also same. So SUT is 180 and SUT is equal to 180 into 9.81. So that will be Newton per mm square 1765.8. Then SYY is the again 0.45 into SUT. So SYY will be equal to 794.61 Newton per mm square. Then S dash SE is equal to 0.22 SUT. So S dash SE will be equal to 388.476 Newton per mm square. Assume that factor of safety NF is equal to 2. The wire diameter can be defined as the tau A upon SSY upon NF minus tau m is always equal to the S dash SE by 2 divided by SSY upon NF minus S dash SE upon 2. So by putting the values, we will get the diameter of the wire diameter for the exhaust valve spring will be equal to D is equal to 5.20. So the final value is taken as D is equal to 6 mm. Then mean coil diameter is equal to capital D is equal to C into D. Therefore, 10 is the uh, spring index and 6 is the wire diameter. Therefore, the mean coil diameter will be equal to the 60 mm. Then number of active coils NC will be calculated by using the formula GD by 8 C cube K. Therefore, by putting the value of G, then wire diameter, then spring index and K, you will get the number of active coils equal to 5.125. So the number of active coils will be equal to 6 turns. After that, total number of coils N dash is equal to N dash C is equal to NC plus 2. Therefore, total number of coils will be 8 turns. Then the maximum compression pressure is the delta max. So that will be equal to delta max is equal to F max upon K. So maximum compression spring del max is equal to 25.5883 mm. Then the solid length of the spring will be equal to LS is equal to NC plus 2 into D. Putting the value of NC, that is the number of active coils and wire diameter. So we will get the LS is equal to 48 mm. Then the free length for the exhaust valve spring is equal LF is equal to LS plus 115 delta max. So in this way we can get the free length for the exhaust valve spring. So here you can see the wall springs design or drawing of the wall spring. So you can see the wire diameter is equal to 6 mm. Then the mean diameter is equal to 60 mm. Then length is equal to 1 mm. So this is the diagrammatic representation of the wall spring used for the inlet wall as well as the exhaust wall. So thank you for watching the design of ICB component wall spring.